Hi, this is Shaul Hamid, Professor ECE, Sedu Institute of Technology. In this session, we are going to solve one problem which is related to Routh Criterion under linear control engineering. First, I will read the problem statement. The characteristic polynomial of a system is given by s power 7 plus 9 s power 6 plus 24 s power 5 plus 24 s power 4 plus 24 s cube plus 24 s square plus 23 s plus 15 is equal to 0. Determine the location of roots on S plane and hence the stability. So they have given a characteristic equation. We need to find the roots, location of roots on S plane, and then we have to conclude about the stability of the system. So for this we are going to use Routh criterion. We are going to form a Routh array in order to find out the stability of the system. If the system is stable, there is no problem, or we can conclude that all the roots are in the left hand side of the S plane, and if the system is not stable, then we have to identify where the poles are located within, in the right hand side of the S plane, and also in fact we have to find the poles on left hand side of the S plane. Now, so the given characteristic equations here, now we have to identify the coefficient of odd and even powers in order to form Routh array. So here highest power is 7. So we have to identify odd power coefficient. Here s power 7 coefficient is 1 and this is 24. Again s power 3 is 24 and then s is 23. Similarly, we have to find the coefficient of even s power. So here starting with s power 6, this is 9, then 24 and 24, and it is this is actually s power 0, so 15. So starting with highest power s7, we are forming odd coefficients. So we just take an odd coefficient, that is 1, then 24, then 23. Similarly, even coefficient 9, then 24, then again it is 24, finally it is 15. After writing it, so when we are seeing this here, when you are seeing the even coefficient here 9, 24, 24, 15, we can divide this entire row by 3. When we are dividing the entire row by 3, you will get 3 and 8, and this is 5. So I am rewriting this array like first there is no change in the first row, and second row instead of 9, 24, 24, 15, we are writing 3, 8, 5 after dividing the entire row by 3. Now we have to form the third row, that is s power 5. This can be determined by multiplying 3 and 24 minus 8 into 1 divided by 3. So this we have written here s power 5. S power 5 is here. So 3 into 24 minus 8 into 3 divided by 3. So when you are doing the same for entire row, we'll get first one is 21.3. The second one is again we have to multiply this one. This can be determined by multiplying 3 and 24 and 1 into 8 by 3. Similarly, this one and this one, that is these two divided by minus these two, 1 into 5 divided by 3. So when we are determining the value, you get the entire row is 21.3. This is also 21.3 and this is also 21.3. So all the coefficients are having same value, so I am dividing entire row by 21.3. We get S5 is 1 1 1. Now we have to form the next row, that is S power 4. This can be determined by multiplying this element, that is 1 and 8 minus 3 and 1 divided by 1. So I have written here, so 1 into 8 minus 3 into 1 divided by 1, that is 8 minus 3 divided by 1 is 5. So I am just writing 5. Similarly, 1 into 8, then 1 into 3 by 1, again the same value 5. Finally 1 into 5 minus, here it is 0, so 0 into 3 is 0, divided by 1 it's 5. Again S power 4, this here also all the elements are same value, so we are dividing the entire row by 5. We get S power 4 is equal to 1 1 1. Now we have to form the next one, next row, that is S cube. Here S cube, when we are finding, so first we have to multiply 1 and 1 divided minus 1 into 1 by 1. So 1 minus 1 is 0. So S power S cube is equal to 1 into 1 minus 1 into 1 by 1 is equal to 0. So similarly the next one, this also 0, because this one and this one minus 1 into 1 is equal to 0, because both rows are having same coefficient value, so you get 0. So the entire row becomes 0, hence we cannot further proceed, because anything by 0 is 0. So if you are proceeding, all the elements in the Routh array may become 0, the further rows will become 0, hence we have to use another technique, that is we are going to form a equation based on S power 4. Here we have 1 1 1 3 coefficient. We are forming equation related to this row, that is the row which is all 0 row, the previous row we are taking. So when you are forming is, this is the coefficient, the first element, this is the coefficient of S power 4, and this is the coefficient of S square and S power 0. So we are forming the equation like A is equal to S power 4 plus S square plus 1. Now we are differentiating this equation with respect to S. We get, when we are differentiating this equation, 4s cube plus 2s square plus 0. So we are replacing the zeros of entire row by the coefficient after differentiating the previous equation, that is A is equal to S power 4 plus S square plus 1. Here coefficients are 4 and 2. Simply I am replacing the zeros with the coefficient 4 and 2. Here when you are seeing these coefficients, these two are divisible by 2. So when you are dividing 4 by 2 is 2 and 2 by 2 is 1. So I am just considering 4, instead of 4 and 2 I am just putting 2 and 1. Now we have to follow the same procedure to find out the next row coefficient. So 2 into 1 minus 1 into 1 divided by 2, that is 2, these two, that is these two values, 2 into 1 and then 1 into 1 divided by 2, that is 2 into 1 minus 1 into 1 by 2 is equal to 2 minus 1 by 2 is equal to 1 by 2 is equal to 0.5. So 0.5. Similarly 2 into 1 and this is 0 0 to 0, 2 into 1 divided by 2, 2 by 2 is equal to 1. So this is the value of 1. So now we have to form another two rows, that is s power 1. S power 1, again we have to multiply 0.5 into 1 minus 1 into 2 divided by 0.5. When you are doing that, you get minus 3, and finally we can, and here of course we won't get anything because here others are 0. So the finally we get 3 into 1, 0 into 0.5 is 0. So minus 3 divided by minus 3 is 1. So this is the row. Here when we are seeing this, after forming the Routh array, we have to see the first column. When we are seeing the first column, if all the entries are positive and real, then there is no problem. All are positive, then it is not a problem. We can say that the system is stable. But here we find one coefficient is minus, that is negative, and also we can find two sign changes, that is 0.5 to minus 3 and minus 3 to 1. So if we find two sign changes, hence we can say that the system is unstable, and we can say that there are two roots are lying on right hand side of the S-plane. Then we have to find the roots. What are the roots which are lying on right hand side of the S-plane? So this is the conclusion. The system is unstable. Now we are going to find the roots. For that we have to take the auxiliary, that is equation, characteristic equation, which is previous to all 0 coefficient. We found here s power 3 we got all the coefficients in the Routh array all are 0. So we have to take the characteristic equation formed by the previous one, that is s power 4, okay, and then that is s power 4 plus s square plus 1 is equal to 0. Now we have to put s square is equal to x. We can transform this equation like s square plus s plus 1 is equal to 0. Now we have to find the roots of the polynomial. Now we have a formula, that is this quadratic equation. So we have a formula to find out roots, that is minus b plus or minus square root of b square minus 4ac by 2a. Now we have to substitute the value of ABC in this equation. Here when we are seeing this equation, ABC value is equal to 1. So when you are substituting, we get the coefficient like minus 1 by 2 plus j square root of 3 by 2, or minus 1 by 2 minus j square root of 3 by 2. These are the two roots. Okay. Now this is a complex number. We can write this complex number in terms of magnitude and phase angle. Any complex number can be written in terms of magnitude and phase. When you are taking magnitude, the magnitude value is 1 and the phase angle is 120 for this one, and the second one the magnitude is again 1 and the phase angle is minus 120. But actually we have considered s square is equal to x. Okay, then x is equal to then s is equal to, when you are taking s, we get plus or minus square root of x, because we have to take square root on both sides. We get s is equal to plus or minus square root of x. Now we have to substitute the value of x in this equation. We get plus or minus square root of 1 phase angle 120 degree, or plus or minus square root of 1 phase angle minus 120 degree. So you know that square root of 1 is 1, and when you are taking square root of phase angle, the phase angle value we have to divide by 2. Okay, so plus or minus, so when you are taking square root, we get plus or minus square root of 1, that is 1. 120 degree by 2 is 60 degree. Similarly here also 1 and minus 60 degree. So when you are converting, that is magnitude phase, into complex number, for this case 0.5 plus j 0.866, or plus or minus here, plus or minus here, plus or minus, for this case 0.5 minus j 0.866. Now we have to locate the poles and poles in the S plane. Here when you are taking this one, we have two roots. When you are taking this one, we have two poles. So for example, when you are taking the first one, this case you get minus plus 0.5 plus j 0.866 and minus 0.5 minus j 0.866. When you are taking this one, we get two poles. One is plus 0.5 minus j 0.866 and another one is minus 0.5 plus j 0.866. Now we have to locate the poles. So first one is, so this is x and y graph, this is S plane, and x-axis sigma and y-axis j omega. So first one is, we are locating this one, the first pole. Okay, 0.5 plus, that is real one, and imaginary is 0.86. So 0.y is in between 0 and 1, this is 0 and 1, so center point is 0.5, and 0.866 is very close to 1, so this point, so this is 0.5 plus j 0.866. Similarly, we can locate all the poles and we can conclude that these two poles are located in right hand side of the S plane, and these two poles are located in left hand side of the S plane. Hence, since it has a pole, it has since there are two poles on right hand side of the S plane, we can conclude that the system is unstable. Okay. Thank you very much.